So this is the level 2 certificate in further maths paper 2 calculator paper. So this is the level 2 certificate in further maths paper 2 calculator paper for 2021. So question 1. Expand and simplify. Relatively easy, could have this at GCSE. So we're going to expand the first brackets to get 10x, take away 5, and then the second brackets 44, take away 4x. So if we collect like terms together, put 10x minus 4x is 6x, and minus 5 plus 44 is 39. It then wants our answer in this form here, so it's in factorised form. So we need to factorise out a number. So 3 goes into 6x and 39. And then 3 times 2x gives me 6x. And 3 times 13 gives me 39. Question 2. So 5m is decreased by 40% and the answer gives you m plus 1. So we need to generate an equation from the information given. So if I decrease something by 40%, I start off with 100%, taking off 40%, so that means I've got 60% of that amount. So if I want to find 60% of something, I'm going to multiply by 0.6. So I'm going to multiply my 5m by 0.6 to decrease it by 40%. And when I do that, I get an answer of m plus 1. 0.6 times 5m would give me 3m. So if I solve this equation, I end up with m equals a half. So again, something you could get at GCSE. Next is another solving an equation, similar to what was on the paper 1. So think about rearranging. If we have got the cube root, on the other side we want to cube. So on the other side, I'm going to do 18 cubed. Which gives me 5,832. So if I solve that equation, and divide by 2, okay, and it's obviously quite a good idea to check your answer so you can substitute that back into the equation. So if I sub that back in, you should end up with 18. So a good way of checking. If you have got a GDC, remember you can go to equation solver and just type that equation in. So we want the cube root of 2x minus 10. It's going to give you 18. Okay, so then you know that you have got it right. In the GCSE exam, you do get full marks for the right answer. I wouldn't recommend that because you would lose full marks if you type it in wrong. Okay, but using those sort of tools is a really good way of checking your answers. So always make sure with everything you're checking your answer for accuracy. Question 3. Sorry, I didn't want to scroll. So the rectangle and the triangle have got equal areas. And we want to work out D divided by E. Okay, so if we work out the area of the rectangle, I'm doing 2D multiplied by 12DE, so 24D squared E. For my area of my triangle, I've got half base times height, so half 8e squared and 9d. So we've got 36 e squared d. And then obviously we know these two things are equal. Haven't left too much room over here. So 24 d squared e is the same as 36 e squared d. So if we're trying to find d divided by e, I've got a d on top on this side. So I probably want to collect my letters on this side and my numbers on the other side. So I'm going to do 24 divided by 36. So a bit like cross multiplying, but cross dividing, I suppose. And then we've got e squared d on this side, and I'm dividing by d squared e. Okay, you can cancel down 24 divided by 36, 2/3. Okay, and then actually what happens when you cancel out, since what is happening, so your e is going to cancel and your d is going to cancel on the bottom. Okay, so one d and one of those d's. So actually I've worked out e over d, but I can just flip that upside down. So the answer would be 3/2. Question 4 is about circles, so circular graphs. We want to work out the shaded area. So this question is asking you to identify, basically, do you know what the radius of these graphs are? Okay, so remember the form of an equation of a circle, it's x squared plus y squared equals r squared. Okay, so if this is r squared, it gives me a radius of 10, and if this is r squared, it gives me a radius of 6. So I know this is 6, and this is 10. Okay, so if I want that kind of inner tube, if I wanted the whole of the inner tube, I'd obviously do the larger circle, take away the smaller circle. So your area of the large circle is pi times r squared, which is pi times 10 squared. So 100 pi. Area of the small circle is pi times 6 squared. So 36 pi. So if I subtract them, 100 pi, take away 36 pi, I'm going to get the whole of this inner space. And obviously I only want a quarter of it. So I'm going to divide it by 4. It wants my answer in terms of pi. So if I work that out, I've got 16 pi. Question 5. So we've got SQR is a right angle triangle. So just double check everything information is on your diagram. So P is just a point on SQ. SPR is 45, that's on your diagram. M is the midpoint, so make sure you know M is in the middle. And K, which is your x-coordinate of R, is a constant. So we're trying to find out what that midpoint M is. So quite a lot of information going on here. So in this sort of question, just work out anything that you can possibly work out. So if I'm thinking about this small triangle here, okay, I've got a right angle triangle. I know the angle in it. And actually, if I want the x-coordinate of R, it might be helpful to work out what this side here is. Okay, but to do that, I need to know another side. So if you think about your y-coordinates, I'm going to just map them across to the y-axis. Okay, this one's got a y-coordinate of 1. This has got a y-coordinate of 6. This has got a y-coordinate of 15. So actually, I know that this side here is 9 units. Okay, so I can use that, just use normal trigonometry to work out the opposite side. So I've got the opposite side and the adjacent side. So if we think of SOHCAHTOA, my opposite and my adjacent, I can use the tan ratio to work out what that opposite side is. So tan 45 is my opposite side divided by my adjacent, which was 9. Okay, tan 45 is 1. So that makes my opposite side 9 as well. Okay, so if that is 9, I'm going to do the same with my x-axis. So this was the x-coordinate was 1. This is what we're trying to find out. And it'd be really helpful if we had the x-coordinate of r. Okay, so if we know this side up here is 9 now, not a question mark anymore. Okay, if it starts at 1, it must end up at 10. So we now know k is 10. Okay, so now you've just got the midpoint between 10.15 and 1.1. So to find the midpoint, you average your x-coordinates and you average your y-coordinates. So our x-coordinates are 1 and 10, and our y-coordinates are 1 and 15. So we've got 11/2 and 8. So it's quite a nice question, a little bit of right angle trig mixed in with coordinate geometry. Next question is on rearranging, so we're trying to find W. So if we've got a square root, the best thing to do is square both sides. And then dividing by 3. So I need to multiply by 3. I'm going to move the x, so I want to subtract x from both sides. And then divide by 2. So relatively simple rearranging. Question 7. So work out the value of m for which this is true. So this is testing your knowledge on index rules. So when you've got power and another power, we can multiply those powers. So the first side will be the same as a to the 4m, and the next one will be the same as a to the 10m. Okay, so a is a number that's greater than 1. We want to find the value for which this is true. So when does 4m equal 10m? Okay, and if you think about it, that is only true when m is 0. For part B, write y in terms of w and x. So it's another little bit of rearranging. So I'm going to keep y to the 5 as a subject and divide through by w cubed x squared. So if you think about your knowledge of indices, we're dividing, so we subtract the powers. So this will give me w to the 10 and x to the 5. Okay, to get y, you want to do the 5th root of that. So remember, the 5th root is the same as doing to the power of a 5th. So if I think about what we just did with the indices, I can multiply them again. So 10 times a 5th is 2, and 5 times a 5th is 1. But obviously I don't need to put 1. So w squared x is your final answer. Functions question for question 8. So it's giving you a piecewise function. And it gives you the sketch of those parts. And we want to work out all the values of x for which f of x is minus 12. So just because it's a piecewise function, so remember, a piecewise function is where you've got the multiple sections to your graph. Okay, we're just going to do the same thing we would normally do. If we're trying to find my fx equals minus 12, think about on the graph. So say minus 12 is here. You would just draw a line across. And we're looking for these intersection points. So you can see you're going to have 4 solutions. Okay, so really we just want to solve where each of those graphs equals minus 12. Okay, so we want to solve 4x, which is the first one, equals minus 12. We want to solve x squared minus 8x equals minus 12. And we want to solve 16 minus 2x equals minus 12. Okay, so you can do this on your calculator. You could draw the graphs. The calculator won't do a piecewise function for you, but it will do the separate graphs. So for example, the first one's quite easy to solve without your calculator. So obviously that would give you x is minus 3. For the second one, you might want to draw x squared minus 8x. And then draw minus 12. Okay, if you change the view window, so press view window, standard, you can normally see most things on there, and then scroll. So obviously it only went down to minus 10. So if you just scroll down a little bit, you can see the graph. So press G solve and intersect. So it tells you x is 2, and press the arrow across, and x is 6. And then 16 minus 2x equals minus 12 is obviously pretty easy to solve, but you could also do that one on your calculator as well if you wanted to. So 16 minus 2x . 16, try that again, minus 2x. And then you've already got minus 12 on there. So make sure you scroll so you can see it. So G solve, intersect, so that one will give you x equals 14. Okay, for those who don't have a GDC, you would have to solve this equation here. So you'd have to move the 12 over to the other side. Okay, and then either complete the square or use a formula. I'd probably go for completing the square. So x minus 4 squared minus 16 plus 12. My preferred method. Okay, and then rearrange. So add 4, square root, plus or minus 2. So x is 4 plus or minus 2. So 2 or 6. But if you don't have a calculator, I would definitely recommend getting one ASAP. Okay, and that was it. So just finalise the answers. Question 9. Circle the expression which is equivalent to 1 over a plus 1 over b. So if you just think about how we add fractions together, we would get a common denominator by multiplying them together. So for the first fraction, I'd have to multiply by b. And for the second fraction, I'd have to multiply by a. And then if you combine them together, obviously your numerator would be a plus b. So it's going to be that last one. To simplify, remember, you need to use factorised form. So if you factorise this top, I can take out c to the power of 3. So I'm left with 6c, take away 1. On the bottom, I've got the difference of 2 squares. So 6c plus 1, 6c minus 1. And then your 6c minus 1 will cancel. So you're just left with c cubed over 6c plus 1. So the radius of the sphere in centimetres is 3k over 2. The volume of the sphere in centimetre cubed is 972 pi. Gives you the volume of the sphere, and we've got to work out k. Okay, so if we're thinking backwards, so our volume is 4/3 pi r cubed. And we know we get an answer of 972 pi. So I can divide both sides by pi straight away. To rearrange this, I need to divide by 4/3, which is the same as multiplying by 3/4. Okay. Or you can just do divided by 4/3 in your calculator. And we get 729. I then want to do the cube root of that. Which gives me 9. So I know my radius is 9. Okay. And they put it as 3 over 2k. So therefore, your 3 over 2k is equal to 9. So if you divide by 3 over 2, gives you a value of k is 6. More expanding in question 11. So just use FOIL as you normally would, but you've just got some harder expressions in there. So 4x times 5x gives me 20x squared. I've then got 3y squared multiplied by negative y squared. So that'll give me y to the 4. And then we've got 3 times 4 is 12. We've got an x and a y squared. And then my last term is 5x y squared. So collect together anything you can collect together. So 20x squared minus 3y to the 4. So you can collect together 12xy squared minus 5xy squared gives me 7xy squared. Right, question 12. So A and B are on the line y equals 3x plus 2. So because we've got the equation of the line, we know that that y-intercept is 2. And we also know B, C, and D 5, 0. So we've got the coordinates of D. So I'm going to pop that on the diagram as well. Our points on the line L. Then gives you the ratio of O to A to A to C. So the ratio of this is 1 to 4. So if I know A is 2, if I multiply that by 4, then I know that this distance here is 8. So my coordinate of C must be 10. So I've got my y-intercept of D, of the line L, sorry. I've also got my point D. So I've got 2 points I can work out the gradient from. So I'm trying to find the equation of the line. So the M is, so we're using the points 5, 0 and 0, 10. So change in my y coordinates divided by the change in my x coordinates, which gives me a gradient of -2. So I know that line L has got the equation y equals -2x plus 10. I then want the intersection point of 3x plus 2 and -2x plus 10. So I can make them equal and solve this equation. Okay, and we can use a calculator to double check that. So if I put the graph of 3x plus 2 in, and then put the graph of -2x plus 10, then I can press G solve, intersect, and intersect a 1.6, which is obviously the same as 8/5. Question 13 is a differentiation question. So as soon as it says in the question about the gradient of the normal, you should be thinking, I've got to differentiate. So if I differentiate y, so bring the power to the front, take one off the power, bring the power to the front, take one off the power. So our gradient function is 3ax squared plus 20x. That gives you the gradient of the tangent, remember. So at x equals 2, my gradient is 3a times 2 squared plus 20 times 2. So 12a plus 40. Okay, remember that gives you the gradient of the tangent. This question gives you the gradient of the normal. So if your gradient of normal is minus a quarter, that means your gradient of your tangent must be the negative reciprocal of that, so 4. So we know that 12a plus 40 is going to equal 4. Okay, and then you can solve that to get a is negative 3. Question 14. So we want the transformation represented by A. Okay, so remember, think about a unit vector. I'm going to do different colours. Okay, so if we think about the unit square, remember that represents the matrix 1, 0. So that's our, let's do the right colours. So 1, 0 represents our unit vector on the x-axis. And then 0, 1 represents our unit vector on the y-axis. Okay, so if we think about what's happened, 1, 0 hasn't changed. So this column here has not changed. So the purple one is going to be in the same place. But 0 minus 1 has moved. So my blue vector has moved to 0 minus 1 instead, down here. So you can see from that diagram that that shape has been reflected in the x-axis. So your answer is a reflection in the x-axis. Okay. If we think about the next one, so b squared if we multiply those matrices together, so remember you do 0 times 0 and then 1 times minus 1 and add them together, so it gives you minus 1. This one here will go along and then down, so 0 times 1 and 0 times 1, so that gives you 0. This one here, go along and then down, so minus 1 times 0 and 0 times 0 again. And then for the last one, you're going along and down, so minus 1 times 1 is minus 1 at 0. Okay, so if we draw minus 1, 0, and 0 minus 1. So let's go with blue, purple there, and blue here again. Okay, so your purple one is first column, so it's gone minus 1, 0. So it's gone back here. So minus 1 across 0, up and down. And if you think about the blue one, that's gone 0 across and minus 1 down. Okay, so if you look at that diagram, what has happened is a rotation 180 degrees. about 0, 0. Okay. Circle theorems. So let's have a look at this diagram. We've got angle BCD is W, and we know the OAB is X. So these questions, if you think about any other angle you can work out. Okay, now this is an isosceles triangle because OA and OB are both the radius. So you know you're going to have another X in there. So I'm going to write OBA is X as it's an isosceles triangle. That then allows me to work out this angle here. So AOB is 180, take away X, take away another X, so 180 take away 2X. Just because of angles in a triangle. I can then use that to work out ACB. So ACB is going to be half of that angle because this is the angle at the circumference and the one we just worked out was the angle at the centre. So for half that, I'm going to get 90 minus X. So angle at the centre is twice the angle at the circumference. And then W is obviously on a straight line with that angle. So therefore W is 180, take away 90 minus X because of angles on a straight line. So if I simplify that, 180 minus 90 is 90, minus X gives me plus X. Question 16 is a question on binomial expansion. So we're looking at the coefficient of x to the power 4 in the expansion of something to the power of 6. If I just draw out Pascal's triangle. Okay, I can stop. So I'm going to where my power is 6. So where that second number in Pascal's triangle is 6. Okay, and it's quite hard to pick out the coefficient of x to the power 4. So you may just want to start doing the expansion. So I'm going to write it the other way around. You'll see why in a minute. Okay, so I'm going to get my first term to the power of 6. Then I've got in Pascal's triangle 6. And the powers of 2x are going to go down, while the powers of a are going to go up. My next coefficient is 15. This would be to the power of 4, the powers are going down, and the powers of a are going up. So you can see why I switched around the 2x and the a, because I was trying to get to 2x to the power of 4. I know it'd be quicker if I started decreasing the powers rather than increasing. So this is a term we're interested in. We know it's going to come to 1500. So you've got 15 times 2 to the 4 times a squared. So if we rearrange that, it gives me a squared. And then you can obviously square root to get a. So we've got 1500 divided by 15 times 2 to the power of 4. Ooh. 25 over 4. So if we square root that, we get 5 over 2. So for this question, we've got a cube of side length 32. So I'm going to add that to the diagram. M and N are on the edges. And we want to work out the angle the line BM makes with the plane ABCD. So the plane ABCD is the base. So we want to look for the angle between this line BM and this base. So I'm just going to add a diagonal line in here, and that's the angle that we're trying to find. So if we draw out a 2D version of this triangle, this is point B, D, M. Okay, so we don't have any information about that triangle at all. So I'm going to look for the sides. If I look at the side DB, that is on the base. So I'm going to draw out the base in a 2D diagram. This is D, E, A, C. Okay, and it's a cube, so all the sides are 32. So if this is 32, this is 32, I can use that to work out what DB is. So DB squared is 32 squared over 32 squared. And square root that using Pythagoras. So that gives me a value of 32 root 2, which I can then put in our original triangle. So this side DB is 32 root 2. Okay, and then I need to find another side in the triangle, so either MB or M to D. And I've obviously got this smaller triangle up here. Okay, which I can use to work out G to N. So M to N, remember, is the whole side of the cube, so that'll be 32. So if I'm trying to find out G to N, I've got the opposite side and the adjacent side. So tan 28 is the same as G to N divided by 32. Okay, so that makes that 17. I'm not going to round that number, but that is the distance G to N. So G to N is obviously going to be the same as this side here, H to M. So this is also 17.01. Okay, so to work out M to D, I can do my whole side, 32 centimetres, take away 17.01. So M to D, 32, take away that number. So 14.9 centimetres. Okay, and now going back to my original triangle, we've got the opposite and the adjacent again. So tan of my angle is going to equal the answer we had for MD divided by 32 root 2. So if you inverse tan, you get an answer of 18.3 degrees to 3 significant figures. Okay, if we look at number 18, as soon as it sees the word minimum in a question, you should be thinking of differentiation. So I'm going to rewrite y. So it's 3x minus 1. I can then differentiate. So remember, you bring the power to the front and take 1 off the power. To get an expression 12 minus 3x to the minus 2. Okay, and remember the minimum occurs when the gradient is 0. So 12 minus 3x to the minus 2 will equal 0. I'm just going to change that back so it's reciprocal again, so 3 over x squared, so that I can rearrange to find x. Okay, so if we square root, we know our turning points are the square root of quarter, which is plus or minus half. So we need to know which one's a minimum and which one's a maximum. So if you do the second derivative, so differentiate again. So we've got 6x minus 3. Okay, at x equals a half. We can substitute in to find our second derivative. Okay, and because your second derivative is positive, the point x equals a half is a minimum. Question 19. So we've got, gives you the composite function and you have to work out what g of x was. So remember, gf means you've subbed f into g. So g of x plus 2 cubed is going to give you x plus 2 to the 12. So think about it in terms of what have you had to do to x plus 2 cubed to get x plus 2 to the 12. Okay, and we would have had to raise it to the power of 4. So therefore, g of x would have to be x to the power 4. For part B, so h and k are just 2 new functions. So again, it gives you the composite function, and you need to work out what the opposite composite function is. So very similar to part A, we have to work out what's happened. So h of k of x is 4x squared plus 5. So we've subbed the function k into h. So whatever k of x was, we squared it and added 5 to get 4x squared plus 5. So k of x would have to be 2x. So if you do 2x times 2x, that will give us this 4x squared. So now you know the 2 separate functions, you can work it out the other way around. So khx is putting h into k. So we're putting x squared plus 5 and substituting that into our expression for k. Okay, so replace the x with x squared plus 5, and that gives us our second composite function. Question 20 is using identities. So we need to think about anything that we can do to simplify this. So if we look at what we're trying to show, this is all in terms of cos and sine. So we don't really want to have tan in there. So I'm going to replace tan x with sine x over cos x. And then where you're dividing by a fraction, that is the same as multiplying by the reciprocal. And then expanding brackets, I can then collect both fractions together because they've both got the same denominator now. So I need to simplify this numerator. So what I'm going to do, so remember we've got the identity sine squared x plus cos squared x is 1. Okay, so we're used to using sine squared is 1 minus cos squared. However, this identity, it's got cos squared minus 1, so it's the opposite way around. So imagine if you took everything to the other side. That would give us negative sine squared. Okay, so I can replace all of this here with negative sine squared. And then that allows me to be able to factorise. So I've got sine in both terms. So I'm going to factorise sine x out the front. And we've got 2 cos x minus sine x, which allows you to cancel your sine x on the top and your sine x on the bottom. So we're just left with 2 cos x, take away sine x. Okay, and the last question. So this is an identity, there's no identity symbol, but it's the same. We could write it as 3x squared plus 2bx plus 8a is identical to this other side. So remember, with identities, you have to expand all the brackets and equate coefficients. So I'm going to expand my brackets for x plus a. So remember, it's x plus a multiplied by x plus a. So once you've expanded those brackets, you can multiply through by 3. Okay, and then we're equating coefficients. So we're looking at what's in front of the x. Okay, so if we look at what's in front of your x, so the coefficient of x here is 6a, my coefficient of here is 2b. So we know that 2b has got to be the same as 6a. So not much you can do with that, but you can put b in terms of a. So that means b is 3a. If we look at our constant, I've got 8a on the end, and I've got all of this here. So 8a has got to equal 3a squared plus b plus 2. Okay, but we've just worked out that B is 3A over here. So I'm going to sub that in so everything is in terms of A. It's 3A squared. B I'm replacing with 3A. Okay, and then we've got quadratic in A to solve. So if we go to equation solver, we've got 3 minus 5 and 2. So we've got two values of A, we've got 1 and we've got 2/3. Okay, so then we've got two values of B as well. So B was 3 lots of A, so B is 3 and B is 2. Okay, and that is the end of the paper 2.